Good morning, everybody. Myself, Dr. S. Jyoti Lakshmi, Assistant Professor, RMK College of Engineering and Technology. Today, our topic for discussion is batteries. We are going to see the history of the battery when it was evolved. In the year 1771 to 1800, the Galvani-Volta controversy was there. Initially, the galvanic said that is Louis Galvani observed that because of animal electricity was produced. He used two, that is the legs of the frog was clamped in between a steel plug and it produced electricity. And he observed that the electricity was produced from the animal. Next, our Alessandro Volta came into existence and he found out that it was not because of the animal, it is because of the metal which is being clipped in between the paws of the frog. And in the 1800, the first battery was being evolved and it has been evolved in the form of a pile. It was called as voltaic pile. Layers were placed as a pile and this is how the first battery looked like. The next, in the year 1821, first electric motor was evolved, and in 1835 the first battery electric vehicle was being evolved. And in 1839, the fuel cell, that is the gases, hydrogen and oxygen being used to produce the electric current without combustion. In the same way, gases were used to produce the fuel cell, and the first fuel cell was evolved in the year 1839, and it was done by Sir William Group. This is how the batteries nowadays look like. Now coming to actual term, what are batteries? So batteries are nothing but it is not new term. They are electrochemical cells which are connected together in series, and batteries are nothing but it is a storage house of current. And we know that it is a source of direct electric current at a constant voltage. So cell is consisting of one anode, one cathode and an electrolyte. Battery is a combination of many cells. So batteries is called as the storage house of electric current. Now we know that there are two types of batteries, primary battery and a secondary battery. What is the primary battery? Primary batteries are non-rechargeable battery. We can also call it as use and throw battery. You can use it single time and you can get the energy from it. And after the usage, the battery has to be thrown off. There, the electrodes and the electrode reactions are not reversible. Once it is used, it has to be discarded. On the other hand, the secondary batteries are called as voltaic cells where the electrode and the electrode reactions can be reversed. On the other hand, they are rechargeable battery. When external current is provided from the external circuits, the electrodes and the electrode reactions are reversed so that it can be recharged again and again. Now, the same thing, it is given as a difference here, primary cell and the secondary cell. I've told you primary batteries are non-rechargeable, secondary batteries are rechargeable and can be used multiple times. And in the primary battery, the cell reactions are not reversible. On the other hand, it cannot be recharged also. On the other hand, the secondary batteries, the cell reactions are reversed and can be rechargeable. Primary batteries are cheap. On the other hand, secondary batteries are expensive, and primary batteries can be used as long as the materials are active in their composition. Example of primary battery is like stainless cell, and on the other hand, secondary cells can be used again and again, which is rechargeable battery. Lead acid battery, lithium battery, nickel cadmium battery are called as secondary batteries. Lithium ion batteries are called as secondary batteries. This is the primary cell, or we also call it Leclanche cell, where the primary cell, as we all know it, it is a irreversible cell which cannot be reversed. once after the usage we can use that and we have to throw it outside. Now we also call this primary cell as dry cell also. So it consists of a zinc container. The outer jacket is made up of zinc, and the inside part is made up of carbon. The reason why we use carbon or graphite is we need a material to allow the electrons to pass through. Here, the components will be made as a paste. That is, the electrolyte will be your manganese dioxide, ammonium chloride, and powdered carbon mixed together and made it paste and put it inside the zinc tin, and inside that we have our carbon, which is allowing the electrons to pass through from the anode to the cathode. Now this is the reaction that takes place at the anode. Our anode is zinc, so zinc undergoes oxidation, so we call it as oxidation because here loss of electron is taking place, so it is oxidation. So zinc will undergo oxidation. So Zn is oxidized to Zn2 plus by giving away two electrons. On the other hand, cathodic reactions, cathode here will undergo reduction. So that's why I told you that here our components that we use here is your manganese dioxide, ammonium chloride. So here the components are your cathode, but that cannot allow your electrons to pass through it. That's why we need the help of the carbon rod. So ammonium, that is ammonium chloride, it dissociates as ammonium plus manganese dioxide plus 2 electron. 2 electron is donated from the anode. So that will be taken up by the cathode and it gets reduced. So ammonium will be converted into ammonia gas. Then manganese dioxide is converted into manganic oxide. So this is getting reduced. Manganese dioxide is getting reduced to manganic oxide by liberating water. The overall cell reaction. This is called as overall cell reaction because we are combining both the anode as well as the cathodic reaction. So the overall cell reaction is MnO2 plus ammonium chloride plus zinc gives ZnNH3 twice Cl2 plus Mn2O3 plus water. So this is how the reaction goes on. So after the usage, if we see the primary battery, after the consumption, the black part of this manganese dioxide will be converted to the formation of white paste inside. If after the usage of the battery, if we break the battery and we could see the changes that reaction has taken place. So for today's class, we will stop with this and we will continue with the remaining in the next class. Thank you.